Okay, so by now you've probably already finished, and let's go ahead and see if I can click on this. Hold on, let me see if I can remember how to do this. Hold on. Oops, to daisy. Shoot, hold on, guys. Hold on. Here we go, zap. All right, I was gonna try to remember how to do something and I can't remember. That's okay. All right. So hopefully by now you would have come up with something close to this. Maybe not exactly the same, but something similar. Okay, so for instance, on transcription, you can see that I wrote it occurs in the nucleus. It had the DNA is where it unzips. The mRNA nucleotides copy the DNA code into mRNA codons, okay? And then for translation, you can see that I said it occurs in the cytoplasm at a ribosome. It's a single strand of mRNA where it docks at a ribosome. The tRNA nucleotides are then going to bring in amino acids, and then whichever, you go on and on and on. There's a whole bunch of things you could say. So it just gives you some idea of the kinds of things that I would hope that you would have come up with, okay? All right, so in terms of our central dogma, here you can see the fact that there's a little visual here. I got to move this out of the way here. And so again, you have your cell, you have your nucleus, you have your DNA, your double strand, it unzips, it exposes the part of the code that has that information that's necessary. The mRNA nucleotides come in, they produce a single strand, copying or transcribing that code. Then they leave through as that single strand through a nuclear pore. They go to find a ribosome, they dock at the ribosome. The ribosome at that point is where it's going to be translated. And then at that stage, the tRNAs then come in. And when the tRNAs come in, they are then going to be transporting the amino acids. So your DNA is your information, your mRNA is the message, and then your protein is what your final product is. And so when you're going from getting the information to the message, we refer to that as transcription. When you're going from the message to the product, we refer to that as translation. So transcription, okay, that's the first part. That's where the DNA needs a messenger to bring its information outside the cell where the proteins are made, because remember, the DNA doesn't leave the nucleus. And the DNA transcribes the message in the form of mRNA, messenger RNA, which describes how to make that protein, okay? And then when you get to the second part, which is translation, that's where your mRNA carries that message to the ribosome that's outside in the cytoplasm. And then on a ribosome, the mRNA or that message is going to be translated into that sequence of amino acids, which forms that protein. And that's going to be the product that's going to be made. So transcription and translation, those are the two major components of protein synthesis. That's your central dogma. So how are we going to use all this information? Well, your genotype, again, that's the genetic information. So you can see here, it's where your nucleotide sequence is. So that portion of your DNA, once it unzips and exposes, that's going to be your genotype. Okay, so that's the genetic makeup of an individual. The phenotype, on the other hand, is how that genotype is being expressed, how it's visibly observed, whatever the trait looks like. Again, is it a detached or is it an attached earlobe? Okay. So your genotype and transcription with RNA, and then you're going to have a translation making your protein. And then whatever that protein is, that's what's going to show you what you would look like, okay? So how would you define the difference then between genotype and phenotype? Take a second and see if you can figure out how you would do that. How would you define the difference between a genotype and a phenotype? Take a moment to do that. Take a second. I'm going to stop this for just a second so that you can do that.